In this DeBacco University video, I'm going to be going over the VESPR theory, which is short for valence shell electron pair repulsion, and is the basis for understanding molecular geometries. Alright, so what is the VESPR all about? Well, the VESPR theory is based on the idea that electron pairs around a central atom repel each other, so they arrange themselves as far apart as possible to minimize repulsion. This basically determines the molecule's geometry. While we won't get into geometry, we're understanding a little bit about the forces that are going on that cause the molecules to take on different shapes. So some key concepts are the electron groups, as these include the bonding pairs, which can be single, double, or triple bonds, the lone pairs, which are non-bonding electrons. We see them represented here. And the steric number is the bonded atoms plus the lone pairs on the central atom. As a result, the shape depends on the number of electron groups and whether those groups are bonding or those are lone pairs. So we can see here the X is representing lone pairs. Here the kind of bubbles show that kind of area of that negative charge of those electrons, and then the lines represent the bonds for these particular molecules. Now, why does this generally matter? Well, understanding molecular geometry helps you predict the polarity. Is the molecule polar or nonpolar? Also helps you make predictions on reactivity based on how it interacts with other molecules, as well as physical properties like boiling point and solubility. And you see a couple of the outlines here and the bond angles, the diagrams, and the basic shapes all provided in this summary table. So electron groups as they relate to lone pairs. Well, if we kind of look over here, bonding pairs, as a reminder, are single, double, or triple bonds, and they simply count as one group. The lone pairs are the non-bonding pairs of electrons, and they exert more repulsion than bonding pairs because they're localized closer to the nucleus and aren't shared between atoms. Which is why you tend to show them as these little bubbles, is that's kind of the force field, so to speak, of those electrons. This extra repulsion means lone pairs can distort molecular geometry. We can start to see some changes occur. We start to get those lone pairs, how things want to repel from one another. That's going to cause that molecule potentially to take on these changing shapes. So common geometries as predicted by VESPR is the steric number, again the bonded atoms plus the lone pairs on the central atom, and those lone pairs, as a reminder, are the non-bonding pairs of electrons. And when we start to look at different things here, we can see the steric number, the lone pairs, the molecular geometry, and a couple examples. And we also see them visually represented here as far as the general geometries and the different notations that do occur. I'll have another video on all of the specific molecular geometries in a little bit more detail, giving you a better visual of all of these. So the core principles of VESPR are that the electron pairs, bonding and lone pairs, repel each other. Molecules adopt shapes that minimize repulsion. Lone pairs repel more strongly than bonding pairs, and multiple bonds count as one electron group. So understanding these core principles of VESPR will hopefully provide a background and allow you to understand what's going on with molecular geometries in greater detail.